You are welcome to Davetuts Academy, where we build academic excellence in students for their STEM subjects. If you are coming to the channel for the very first time, you are welcome. For our returning subscribers, you are also welcome again. Today, what we want to look at is the detailed solution to the past question on WAEC Mathematics, and we are going to be solving all of the questions. So, tighten your belt. The journey is going to be quite long, but you are going to learn quite a lot of things. Now, it's not only relevant for students of WAEC. If you are doing your NECO, you are doing your GCE, which is the private WAEC, this is also going to be quite useful for you. All we want you to do is for you to go out there and be the best that God had created you to be. And so, before we go ahead, I would just like to say, don't forget to subscribe to the channel, like the video, share with your friends, share with your loved ones, share with your younger ones. We can all become very good in our academic excellence if we put in the right effort. Somebody once said that proper planning prevents poor performance. And here, for you to be here, checking out this video is an indication that you want to be well prepared for your exam, and by God's grace, excellence will not elude you. So let's go to our video and learn together. Now, our very first question is here. We are looking at a used car that was purchased at 900,000 naira and is value depreciated by 30% in the first year, and in each subsequent year the depreciation was 22% of the value at the beginning of that year. So if it is bought on March 2011, we have to find the value of the car by February 2015. Now, in the year 1, there is a 30% depreciation. So after that year 1, the new value will be 100% minus 30% of its original value. If it depreciated by 30%, then the new value will be 100 minus 30% of the original value, which is 900,000 naira. And so that will give us 70% of 900,000 naira. And by the time we have to calculate that, that will be 70 over 100 times 900,000 naira. And if you bring in our calculator and we calculate that, we have 70 divided by 100 times 900,000. That will give 630,000 naira after the first year, in which the depreciation is by 30%. So now, by the end of by the year 2012, the value is 630,000. Now, for the year 2013, 14, and 2015, we are told that the depreciation was 22% for these 3 years. It's the same value of depreciation, 22% for these 3 years. And that means the value that we're going to get after this period that elapsed, that is the final value by February 2015, is going to be now 100 minus 22% of the value of the start year, which is 630,000. But remember, we are looking at 3 years here, so we are going to raise that percentage by the power of 3, representing the 3 years. So we are going to have 78 over 100 raised to the power 3 multiplied by 630,000 naira. Now, it's because it's 3 years, that's why we are raising depreciation over 3 years. I didn't mean that it's only 2 years. We raise the depreciation over 2 years, raised to the power of 2. So here we can have 78 divided by 100 raised to the power 3 multiplied by 630,000. That will give us 298,976 naira and 76 kobo. Right? Now we're asked to find the answer correct to the nearest 100 naira. That means we are going to take the 9 and round it up to 1 and add it to 8 in rounding up, and that will be 299,000 naira. And that's the value of the car by February 2015. Now, question number 2 here, we are told that the graph of y is 2px squared minus p square x minus 14 passes through the point 3, 10. What we need to note is that 3, 10 represents x, y. And here, if we are to find the values of p, what we need to do is to substitute the value of x and y to be 3, 10 in the original equation, and then we can solve for p. So, from our equation, y is now 10, we have 2p, x is 3 square, minus p square, x is 3 minus 14. If you are to take 14 to the left hand side, it will become plus, so we have 10 plus 14 equal to 2p, 3 square is 9, minus p square and 3. That will give 3p square. So here we can have 24 is equal to 18p minus 3p square. Now if you want to put everything on the same side, we want to take everything to the left hand side, we will have 3p square minus 18p. The sign changes when they cross the equal to. So now we can see that all can be divided by 3, because 3 is a common factor. So we have p square minus 6p plus 8 is 0. Now this is giving us a quadratic equation that we can solve. We can look for the product 8. What two numbers can we multiply to get 8, and yet we'll add them to get minus 6? Now we can consider the numbers minus 4 and minus 2. If we multiply minus 4 and minus 2, the negative will cancel out to give us 8. And if we add minus 4 and minus 2, that will give us minus 6. So those are the numbers we can use. And here we can have p square minus 4p minus 2p plus 8 is 0. So that p square, we can factor that p out, p into p minus 4 minus 2 into p minus 4. Now when these negative numbers, when they multiply, they will give positive 8. So we are on track. If we factor that out, we have p minus 2 is equal to 0, or p minus 4 is equal to 0. And that will give p is 2 or p is 4. Those are the values of p that were asked to find. Good. Our question number 2b, we are told that two lines which are given by these equations intersect at the point Q, and we have to find the coordinate of Q. Now, if we understand the concept of the graph very well on our Cartesian coordinates, whenever we draw two lines, and they intersect at a point, the point they intersect is the unique solution to those two lines. The equation of those two lines have a unique solution at the point in which they intersect. Meaning that this is just a set of simultaneous equations that we can solve, and the solution to that simultaneous equation will give us the unique solution, that is the coordinate of the point Q where they intersect. So if you write out our equation 1 and 4y plus 5x minus 5 is equal to 5 as equation 2, we can look at this, and if we want to eliminate y, we can multiply equation 1 by the coefficient of y in equation 2. So here we are going to have equation 1 multiplied by the coefficient of y in the second equation, which is 4, and equation 2 multiplied by the coefficient of y in the first equation, which is 3. If we are to expand that, we have 4 into 3y minus 2x equal to 4 multiplied by 21. We'll multiply on both sides, and then equation will yield 12y minus 8x. 4 multiplied by 2x is minus 8x. Then 4 times 21 is 84. Then the other one, we have 3 into 4y plus 5x equal to 3 into 5. So if you open a bracket, we are going to have 12y plus 15x equal to 15. Now, 12y is common to both. We can subtract the second equation from the first equation. Then we can have only the variable x to solve for. So if you are to subtract like that, 12y will cancel out. That will cancel out. So we have minus 8x minus 15x is equal to 84 minus 15. So this will yield minus 23x is equal to 69. Alright. So if you divide through by minus 23, minus 23 will cancel out, and then here we'll have minus 3 when we divide 69 by minus 23. So x is minus 3, and this value of x we can use in equation 1 or equation 2 as we so desire. Here I'll be using equation 1. So from equation 1 I can substitute the value of x to have 3y minus 2 into minus 3 is 21. So 3y, the negative we multiply each other to give us plus, that will be plus 6 is 21, so that my y is 15 over 3, and that is 5. So solving for x and y had given us the coordinates of the point Q where the two lines where they intersect, and that coordinate is 3 minus 3, 5. Alright. Another question here. We are told that the diagonals of a rhombus are 10.2 centimeter and 9.3 centimeter long. So we have to find the perimeter of the rhombus. Now, understanding the properties of a rhombus will help us to solve this question. And the key property we need to understand is that the diagonals of a rhombus, normally they intersect at the middle at right angles, and at the point of intersection they are being divided into two. So here, instead of having 10.2 centimeter, the length on the side of this diagonal, half of it will be 5.1 centimeter, and the other one will be 9.3 divided by 2, 4.65 centimeter. So looking at this diagram, we can see that we can get a right angle triangle out of the rhombus as one side of the rhombus. If you are to draw that out, let's draw out our triangle from the rhombus. We have this triangle, a right angle triangle. We have this side as 4.65 and the base as 5.1. Well, let's call the hypotenuse, let's call it x. We can use Pythagoras Theorem to find the value of x. You know that that's the hypotenuse square, and it will be the square of the opposite plus the square of the opposite plus the square of the adjacent, so that our x square will be 4.65 square plus 5.1 square, 47.6325. So x will be the square root of 47.6325. And if we are to check that, square root of that is 6.90163. Okay? 6.190163 centimeter. But nobody asks us to find the value of x. What we are asked is to find the perimeter of the rhombus. Now, if we go back to our diagram, we'll see that the perimeter is the sum of all the sides, and the sides constitute 4x. So our perimeter will be 4 multiplied by 6.90163 centimeter, and that will be 27.60652 centimeter. 60652 centimeter. But we're asked to find this correct to one decimal place. That will be 27.6 centimeter. And that's all about that. Now here we have a trigonometric question. We are given that sine x is 3 over 5 and x is an acute angle between 0 and 90. So we have to find 5 cos x minus 4 tan x. If you remember our SOHCAHTOA, here sine x is 3/5, and that corresponds to opposite over hypotenuse. That means our opposite is 3, our hypotenuse is 5. And if we have to add this particular triangle and label it appropriately, this is angle X. The opposite to it is 3, and the hypotenuse is 5. So we don't know this adjacent. Let's call it A. We can use Pythagoras Theorem to find the adjacent. So if we are to use Pythagoras Theorem, we know that the hypotenuse square, the 5 square, will be the opposite square plus the adjacent square. Our adjacent is A now, and this is coming from hypotenuse square is opposite square plus adjacent square. Now, that means 25 will give 9 plus A square, and our A square will be 25 minus 9, which is 16, so that A is the square root of 16, and that will be 4. Now, that means we've gotten our A, the adjacent, to be 4. If we are to show that in our diagram, this is 4. Now, we can define our cosine and our tangent since we know all the sides of the right angle triangle. So now, what's going to be our cos? What's going to be our tan? Cos is adjacent over hypotenuse, and we have gotten the adjacent as 4. We know hypotenuse is 5. And then tan x. Tan x is opposite over adjacent. Tan x is opposite over adjacent, and that will yield the opposite is 3, the adjacent is 4. So knowing these values, we can plug into the value of 5 cos x minus 4 tan x as requested for in the question. Now we have 5. What is cos x? Cos x is 4 over 5. Now minus 4. What is tan x? Tan x is 3 over 4. Now 5 will cut 5, and 4 will also divide 4, so that we have 4 minus 3, which is equal to 1. Meaning that 5 cos x minus 4 tan x that we are requested to find is nothing but 1. And that's the solution to our problem. Now, going to question 4a. Here we are given the diagram, a circle, and QoS is the diameter, angle RQS is x, and angle QST, the obtuse angle, is 3x plus 15. We have to find the value of x and angle RSQ. Now, there are so many ways we can go about trying to solve this question. But first, I'm looking at a triangle with an exterior angle, and I can say the exterior angle is the sum of the two opposite interior angles, such that I can use that to solve for the value of x. So now the exterior angle is 3x plus 15, which is angle QST. The obtuse angle QST is equal to angle SQR plus angle QRS. Now angle QRS has been depicted as 90, and the other one we know as x. So 3x plus 15 will give us x plus 90 degrees. And if you are to collect like terms, that will be 3x minus x is 90 minus 15. So that 2x is, this will be 675. So if you are to divide by 2 all through, our x will be 37.5 degrees. That means our x is 37.5 degrees. So the first question is solved like that. Now we have to look for angle RSQ. There are also so many ways we can also go ahead to find this. As this is being shaded, we can notice a number of things. It is on a straight line. We can use that to solve for it. If we call it y, alternatively, we can say that from the diagram, since it's a right angle triangle that we are looking at, x plus y is going to give us 90 degrees. And why? Is because they are complementary angles. They are complementary because they are the two other angles of a right-angled triangle. One angle is 90 already, so the other two will add up to 90. So that means y will be 90 minus x, which is 90 minus 37.5, and that will give 90 minus 37.5. That will give us 52.5 degrees. Now, understanding the concepts, the theorems of triangles, circles will help us in solving questions like this. There are so many ways you can use to solve it. Alternatively, to find the value of y, for example, I can consider the line RST, and from the line RST, I can bring in the equation of a straight line, which will sum up to 180 degrees. So I can say from the line RST, 3x plus 15 plus y is 180 degrees. And that's because that's the angle, the sum of the angles on a straight line. And I will still get the same solution to the problem. Alright. So this is our angle RSQ, which is y at 52.5 degrees. Now we have a question in number base. We are given that 2n for base 7 is 15n base 9, and we have to find the value of n. Now, looking at a question like this in two different bases, and yet we are asked to find the solution of the number featuring there, which is n, what we need to understand is that we can solve this easily if we take both left and the right hand side to base 10. So what we need to do is just convert both sides from whatever base they are, convert them to base 10, and we'll see what can come up from there in solving our question. So to convert to base 10, what we need to do is that we take each of the numerals and multiply it by some corresponding power of the base starting from 0. So here 7 from 0, 1, 2, and the same thing we also do to the right hand side. 1 multiplied by 9 plus 5 multiplied by 9 plus n multiplied by 9, then the powers of 9 from 0, 1, 2. Now, this will automatically help us to solve this type of question. If you are to open the brackets, now a silly mistake to do is to say 4 times 7 is 28. No, but here we're having 7 raised to power 0, and any number raised to power 0 is 1. So here we have 4 multiplied by 1 and not 4 times 7. And 9 squared will be 81, 5 times 9 will be 45, plus, again, we have n multiplied by 1. Any number raised to power 0 is 1. So if you are to open our bracket up and do that on both sides, eventually what we are going to have is that we can collect the n to one side so that we have 7n minus n is equal to 81 plus 45, then minus 98 and minus 4 when they move to the right hand side. So we have 6n is the sum of all this. Let me use my calculator here. 81 plus 45 minus 98 minus 4. That's 24. So 6n is 24. And dividing through by 6, you can see that our n will be equal to 4. And that is the value of n that we are asked to find. Alright. Now, in this section here, question number 5a, the mean of mn, s, p, and q is 12. We are to find the mean of n plus 4, n plus 3, s plus 6, p minus 2, and q plus 8. Now, originally, how do you find the mean of a set of numbers? We find the mean by adding the numbers all together and dividing by their frequency. Now, here we have 5 numbers. That means the frequency is 5. And we have been told that that mean is 12. So, if you are to cross multiply on this particular equation we have, that will give us m plus n plus s plus p plus q is 12 times 5, which is 60. So we can keep that because we are still going to find it useful when we are using these other numbers m plus 4, n minus 3, s plus 6, p minus 2, and q plus 8. So now the new mean that we are requested to find will be the sum of all these numbers, n plus 4 plus n minus 3 plus x plus 6 plus p minus 2 plus q plus 8. Everything divided by their frequency. Now, there are also 5. These are 5 numbers because they are put in brackets. So, this is 1, 2, 3, 4, 5. So, that's why we have 5. And now we can say we want to open up the brackets. And let's say we collect all the alphabets together. M, N, S, P, Q plus, now the numerals, 4 minus 3 plus 6 minus 2 plus 8. Everything divided by 5. That will give us our mean. But interestingly, now we are having M, N, S, P, and Q, which we have found to be 60 initially. We found them to be 60 initially. So instead of using those alphabets, we can use 60 since that's their sum. So that will be 60 plus 4 minus 3 plus 6 minus 2 plus 8 divided by 5. Alright, if you are to bring our calculator in, we have 60 plus 4 minus 3 plus 6 minus 2 plus 8. That will be 73 divided by 5, and 73 divided by 5 will yield 14.6. So the mean of these numbers is 14.6. Alright, now our last question in section A. We are told that in a community of 500 people, the 75th percentile age is 65 years, while the 25th percentile age is 15 years. Now we are asked how many of the people are between 15 and 65. If you recall our cumulative frequency curve, the ogive, normally it will be something like this, and we have cumulative frequency on the vertical side, and here we can have the age on the horizontal side. Now we are told the 75th percentile and the 25th percentile. If you are to depict that on the diagram, here we have 25th percentile corresponding to some age and 75th percentile corresponding to some age. Now, this is 65 years and the other is 15 years. And here is the 25th percentile and then 75th percentile. Good. Now, since we have been opportune to know the total number of people in the community, we can easily find the 75th percentile and the 25th percentile, and then to get the number of people between ages 15 and 65, we can subtract that so that our solution can easily come out. So here, the total number of people is 500, and then the 75th percentile will correspond to 75% of 500. So if you cut out, you can have 75 times 5, and that will be 375 people. Okay, and then the 25th percentile will likewise correspond to 25% of 500, and if we also cut out, that will be 25 multiplied by 5, which is 125 people. So now we have the upper age bracket, we have the lower age bracket. The number of people between the 15th and the 65 years of age will now give us this range within the cumulative frequency curve. I'm just showing the curve for explanation purposes, and that will correspond to 375 people minus 125 people, and that will be 250 people. Our question here is talking about a roadworthiness test on 240 cars. We are told that 60% of the cars passed the test, and then there is a whole lot of statistics on the vehicles that failed the test. We are to eventually draw a Venn diagram to illustrate the information and to determine the number of cars that had 40 bricks and then only 1/4. Now, from the information we are given, the roadworthy cars will be 60% of 240 cars. And if you are to calculate that, that will be 60 over 100 times 240. The zeros will cancel out such that we have this to be a total of 144 cars. So 144 cars are roadworthy. They don't have any faults, so they are good to go. If you are to use the first alphabet of the fault, we can use C for clutch, S for steering, and B for brakes. Then we can know that the total number of cars, the universal, when it comes to the Venn diagram set theory, the total number of cars, the universal, you can take that to be 240. We have U is 240. So now we can go ahead to draw our Venn diagram. Okay, so we have clutch, steering, and brakes as the faults that are on the cars. So let's say the yellow is clutch, and then for the steering we use a green marker, and then for the brake, the vehicles with brake issue, we use this 28 only. They are clutch issues, so that will be represented in the circle that is not interfacing with anything. Then we have clutch and steering is 14 as shaded in green, but we've been told that clutch, steering, and brake as shaded now, they constitute 8. So if you have 8 here, if you have 8 in the center, then the other will have to be 6, so that the two will add up to 14 that we are told is constituting the clutch and the steering. Now we are also told that the vehicles with clutch and brake issues is 20. Then 8 subtracted from 20 will give us 12. Then with brake and steering only, the only means that the 8 is not included, so we have 6 here. Then now the number of cars with faults only in steering is twice the number of cars with faults in brake only. So if brake only is X, steering only is 2X. And then 144 cars we have noticed to be roadworthy, they are not 40, so that will be outside the circles. So just like that, we have our Venn diagram for this information that we are presented with, and then we can go ahead to find the other two questions that we are asked to find. Now we are asked to find that how many cars had 40 bricks and how many cars had only 1/4. But here we are finding that we are noticing that there is a variable X that we need to evaluate, and we know that when we sum all of these statistics concerning the cars, they are all going to sum up to 240, which is the total number of cars that we are considering. So 28 plus 2x plus x plus, now the blue statistics, the 6 plus 8 plus 6 and 12 plus the 144 outside is equal to 240. With this, we can see that 3x plus, let's bring out our calculator, 28 plus 6 plus 8 plus 6 plus 12 plus 144, that's 204. So 3x plus 204 is equal to 240. If we collect like terms, 3x will be equal to 36. such that x will be 36 over 3 when we divide by 3 all through, and that will be 12 cars. So our x is 12 cars, meaning that we have all the information concerning this roadworthiness that was carried out, and we can go ahead to find the number of cars with 40 bricks. Cars with 40 bricks are the ones that are in this pink colored chalk. So that will be all the numbers there, 12 plus 8 plus 6 plus x, and our x we have found out to be 12, so we can put 12 there, and by the time we sum all this, we are going to get 38 cars. So the cars with 40 bricks are 38 in total. So now to find the number of cars with only 1/4, the cars with only 1/4 will mean that in the Venn diagram, the cars that are not interfacing with any other, is not intersecting with any other circle. So we have 28, 2x, and x. So the cars with only 1/4 will be 28 plus 2x plus x, which will be 28 plus 3x. And since our x had been found to be 12, that will be 28 plus 36, and that is equal to 64 cars. And that is the solution to our problem. Now, question number 7a, we are asked to find the equation of the line passing through the points 2, 5 and -4, -7. Generally, we know that in the Cartesian coordinate, we write x, y. So the first one will be x1 and y1, and the second one will be x2 and y2. And if you are going to write the equation of a line passing through 2 points, we need to know that this is given as x minus x1 over y minus y1 equal to x2 minus x1 divided by y2 minus y1. Now, in some cases, some people will put the y as the numerator and the x as the denominator. It's going to be the same thing because we are still going to cross multiply. So if you have to plug the value of x1 to be 2, y1 to be 5, x2 to be -4, and y2 to be -7, we can get the equation of the line passing through this point. So we have x minus 2 divided by y minus 5 is equal to -4 minus 2 divided by -7 minus 5. That's by substituting each value of x1 and x2. So this will give us -6 divided by -12. So can cancel out, the negative sign will cancel out. So we have x minus 2 divided by y minus 5 is equal to 1 over 2. And if you cross multiply, that will give us 2 into x minus 2 is equal to y minus 5. Opening the bracket will yield 2x minus 4 is y minus 5. And if we bring -5 to the left hand side, we have 2x minus 4 plus 5 is equal to y, such that our y is 2x plus 1. Now, there is a general format for the equation of a line, and that is y is equal to mx plus c, where m is the slope and c is the intercept. From here we can see that our slope is 2 and the intercept on the y-axis is 1. Now, interestingly, we could have reverted the order of our x1 and x2, and we're still going to get the same equation. Like if we say the 2 and 5 is x2 and y2, and -4 and -7 is x1 and y1, if we plug the same values back into the equation of a line, we'll have x minus 4 divided by y minus -7 is equal to x2 now is 2 minus -4 divided by 5 minus -7. So the negative sign, when they multiply each other, we turn to plus. So we have x plus 4 divided by y plus 7 is 2 plus 4 divided by 5 plus 7. So that we have x plus 4 divided by y plus 7 is equal to 6 divided by 12. And we can also cut out this is 1 and 2. And if we cross multiply from there, we'll have 2 into x plus 4 is equal to y plus 7. And that will yield 2x plus 8 is equal to y plus 7. And if we bring 7 to the left hand side, we have 2x plus 8 minus 7 is equal to y. So y is equal to 2x plus 1. You can see we are having the same value. All you need to do is to be consistent and the answer will easily come out, no matter the one you put as x1, y1 and x2, y2. Here, this is a question on bearing and distances. We are told that 3 shapes P, Q and R are at C, and the bearing of Q from P is 030 degrees and the bearing of P from R is 300 degrees. PQ is given at 5 km and PR as 8 km. And our first task is to draw this in a diagram. So if we go to P and we have to draw our cardinal points, the bearing of Q from P, meaning that we take it from P, is 30 degrees. So if we take 30 degrees from the point P and we go 5 km, that will lead us to point Q. Okay. Now, we're also told that there is another point R. R is going to be down in respect to P, and the bearing of P from R is 300. So we have to measure 300 from the north. That will be 300. And then the distance between R and P is 8 kilometers. So 5 kilometers between P and Q and 8 kilometers between R and P. This is the diagram that we are asked to actually illustrate. We can complete the triangle by joining line Q and R. And from here, we can actually go ahead to find the other questions. If we draw a cardinal point at Q, we're asked to find the bearing of R from Q, and we're asked to find distance between Q and R. Okay, so if we are to zoom in into this figure and try and label appropriately and complete our diagram, let's do that. Now we are zooming in. There is a number of things that we can notice. For example, at point P we have 30 degrees, but if you are to consider this alternate angle between P and Q, we'll notice that at point Q, this angle here will be 30 degrees because it's alternate to the other 30 degrees that we are given as the bearing of Q from P. Then we also go to point Q. We have 390 degrees, that is 270. 300 minus 270 is also 30 degrees. So we also have this angle to be 30. And we have to also consider the alternate angle at point P. That 30 degree will also be equal to this 30 degrees because they are also alternate angles. Now at point P, 30 have been taken out of the right angle. So this other angle will be 60 degrees, and then we are seeing 60 and 90 in the triangle. 60 and 30, that will constitute a right angle which is 90 degrees. So we have completed our diagram, and we can zoom back so that we can solve with this information that we have. With this information now, we can notice that we can find the distance between Q and R and the bearing of R from Q. Now, if we are to draw out this triangle, we are noticing a right angle triangle with appropriate labeling 5, 8, then Q, P, and R. We are seeing that for a right angle triangle, to find QR, which is denoted as x, we can use Pythagoras Theorem, and Pythagoras Theorem will give us that the hypotenuse square is equal to the square of the adjacent plus the square of the opposite. Now x squared will be 25 plus 64, which is equal to 89, and x will be the square root of 89, and here the square root of 89 9.43398. So x, which is the distance between Q and R, is 9.43398 kilometers. But we're asked to find this correct to three significant figures. So we can say the distance between point Q or ship Q and ship R is approximately equal to, in three significant figures now, 9.43 kilometers. 9.43 kilometers. Good. So moving ahead, we can say we want to look for the bearing of R from Q. The bearing of R from Q will take us to estimate the angle that is denoted as question mark at point Q. We will notice from our diagram, from the right angle triangle, that from this triangle PQR, we can use the trigonometric function. Here we notice that tan theta will be opposite over the adjacent, and the opposite is 8, while the adjacent is 5. So theta will be arctan 8 over 5. And arctan 8 over 5 will give us, let's bring in the calculator, arctan 8 divided by 5 is equal to 57.9946 degrees. I can approximate that to 60 degrees directly, since I'm even going to find the bearing, and bearings are not actually including the dot, the decimal places, so this can be approximated to 58 degrees. Now if you have to zoom in into our diagram, that means at point Q we have this to be 58. If you take the 30 out, that will mean the other angle here is 28 degrees. Now if you notice, the straight line coming from the top down to the base at point Q, the angle on a straight line is 180 degrees, and so the angle in the question mark, the bearing we are looking for, will be equal to 180 minus 28. That will be 180 degrees minus 28 degrees. So we can conclude from here that the bearing of R from Q will be 180 degrees minus 28 degrees, and that is equal to 152 degrees. And that is the bearing of shape R from shape Q. Now question number 8a. We are told that Lamin bought a book for 300 naira and sold it to Bola at a profit of X%. Bola in turn sold the same book to James at a profit of X%. James paid 6x plus 3 over 4 more for the book than what Lamin paid for, and we are to find the value of X. Now we know that the percentage profit is the selling price minus cost price divided by the cost price times 100%. And if you are to use this, for each case of transaction that was happening between Bola and Lamin and James, it will help us to actually come up with the solution to the value of X that we are asked to find. Now for Lamin, the cost price for Lamin had been given to be 300 naira. That is as clear as day. But when Lamin is selling, Lamin's profit in percentage, X% that was given, will be his selling price, which we are not told, minus his cost price, which is 300, divided by the cost price, which is 300, multiplied by 100%. Now, if you are to cancel out the zeros and knock out the percentage, we'll see that we can cross multiply to have 3x is equal to the selling price for Lamin minus 300, such that when we collect like terms, the selling price for Lamin will be 3x plus 300. We can know this as a useful equation for us. But we also need to know that the selling price for Lamin is the cost price for Bola. The amount at which Lamin sold the book is the amount at which Bola bought the book. So 3x plus 300 is also the cost price for Bola. Now, Bola in turn also sold the book to James. So Bola's profit in X percentage using the same formula will be the selling price of Bola minus the cost price for Bola divided by the cost price of Bola. But that cost price of Bola has been evaluated to be the selling price for Lamin. So here, if you have to put in the value of the selling price for Lamin, which is the same as the cost price for Bola, what we are going to be having is that X will be the selling price for Bola minus, now the cost price for Bola is 3x plus 300 divided by that cost price 3x plus 300 multiplied by 100. So now if you are saying we want to cross multiply, we'll have x into 3x plus 300 is equal to the selling price of Bola. That will be selling price of Bola minus 3x plus 300 all multiplied by 100. All multiplied by 100. So here we can open up a bracket so that we have the selling price of Bola minus 3x plus 300 is equal to 3x squared plus 300x all divided by 100. We can say the selling price of Bola will be equal to 3x squared plus 300x all over 100. Now, plus 3x plus 300. That is obtained by moving 3x plus 300 to the right hand side. If you are to find the LCM and solve for this to be 3x squared plus 300x plus 100 times 3x plus 300. So, further working on this, you can see that the selling price of Bola will be 3x squared plus 300x plus another 300x from 100 times 3x plus 100 times 300 will be 30,000 all divided by 100. So we should also know that the selling price for Bola is the cost price for James. The amount at which Bola sold the book is the amount at which James bought the book. And from the question, we're told that James paid 6x plus 3 over 4 naira more for the book than what Lamin paid for. So for that statement, if you are to bring it out, that the difference between the amount that James paid and the amount that Lamin bought the book is 6x plus 3 over 4. Now we have gotten the cost price of James, we have gotten the cost price of Lamin. If you subtract the two from each other, we'll have 6x plus 3 over 4. So if we are to try and substitute for these values, the cost price of James is 3x squared plus 600x plus 30,000 divided by 100 minus the cost price for Lamin is 300. All this is equal to 6x plus 3 over 4. Now you have to find the LCM of the left hand side. The LCM of the left hand side will be 100 as the denominator, 3x squared plus 600x plus 30,000 minus 300 times 100 will be 30,000. And we will see that the 30,000 will cancel out so that we have d is equal to 6x plus 3 over 4. Now this will give us 3x squared plus 600x over 100 is equal to 6x plus 3 over 4. So we can clear our work area and write this out fresh so that we can try and solve for the value of x. So if we clear our work area, we have 3x squared plus 600x divided by 100 is equal to 24x plus 3 divided by 4. Now we can divide 4 in 100 is 25. So we have 3x squared plus 600x divided by 25 is equal to 24x plus 3 divided by 1. And if we cross multiply, that will yield 3x squared plus 600x is equal to 25 multiplied by the whole of 24x plus 3. If we open the brackets, we'll have 3x squared plus 600x is equal to 25 times 24 is 600x. We have 600x plus 75. So now, the 600x will cancel out, they will subtract each other. Now we have 3x squared is equal to 75, and dividing through by 3 will cancel out so that x squared is 25 and x will be the square root of 25, which is equal to plus or minus 5. But here we notice that we are talking about a profit margin, so x will be the positive value of 5, and like that we can say our x, it is a profit margin, so x is equal to 5. And that is the solution to our word problem on commercial mathematics. Question number 8b. We have to find the range of values of s which satisfies the inequality. Notice here we have to find a range of value. So now if we have to break this inequality into two, first we have 3x minus 2 is less than 10 plus x, and then we have 10 plus x is less than 2 plus 5x. We can solve the two separately and conjoin our answer. So for the first one, we can say we want to collect the like terms, put x on the same side. So we have 3x minus x is less than 10 plus 2. That will give us 2x is less than 12. And if we divide through by 2, it will give that x is less than 6. Then for this other one, if you also collect the like terms, you can say now 10 minus 2 will be than 5x minus x, and that will give 8 is less than 4x, and dividing through by 4, 8 over 4 will be less than x, so that we have 2 is less than x. Now we have two expression, x is less than 6 and 2 is less than s. Now this we can try to represent on a number line so that we can find the range of values as requested. If we are to depict our number line and we are to appropriately label that, okay, if we are to label our number line, then we are saying that it is only less than that we are having. So that's not going to be a shaded circle, it's going to be an empty circle. And the both cases we can represent, but we know that 2 is less than x is also the same as x is greater than 2. So on the 2, the greater values will be to the right hand side of the number line, and then x is less than 6 will be to the left hand side of 6. So here we have our two expressions joining together, linking up, such that the range, now 2 and 6 will not be included, so the range will be 3, 4, and 5, and that will be the range of values that satisfies the inequality that we're given. Now, question number 9. In this diagram, we are given the parameters PT is 4, TS is 6, PQ is 6, and angle SPR is 30 degrees. We have to find SR and the area of TQRS. Now, looking at this triangle, from the triangle PQT, the smaller triangle at the top of the diagram, we can use the cosine rule to find the line TQ. Using the cosine rule, it will yield us TQ square is 4 square plus 6 square minus 2 times 4 times 6 cos 30. You can easily review this from our other lectures. This targeted at solving the questions. If you want to get some better explanations on this, just check our other videos. And now if you are to put this in the calculator, it will be 16 plus 36 minus 48 cos 30. And that will be 10.43078. So our TQ will be the square root of 10.43078, which is equal to square root of our answer 3.22967. Okay, that's the value of TQ. For us to find the value of the line SR, we can make use of the similar triangles that we are noticing here. We have the smaller triangle and the bigger triangle. They share two sides and they also share an angle. So these are similar triangles that we can actually relate their sides and relate their angles to find the unknown side that we might be looking for. Here, our unknown side that we are looking for is SR. So if you are to use the principle of the similar triangles, we can say we want to use the ratio of the sides. And here, since we know PT and we know PS, we have also found TQ. We can say PT over TQ will be PS over SR. The sides to the left and the side to the base, we can relate them such that we have PT is 4. Now TQ is 3.2297 that we have found out. PS is 4 plus 6, the whole of that length, and that is the whole of that length has been shown. We have 6 and 4, and that will be 10. Then divided by SR that we are looking for. Now, if you cross multiply, we will see that the line 4 SR will be 10 multiplied by 3.2297, such that our SR will be 32.297 divided by 4, and that will be equal to our answer times 10 divided by 4, 8.0742. Now, we're asked to find correct to the nearest whole number, and the whole number here will be 8 centimeters. That is the value of SR that we are asked to find. So now we can go ahead to try and find the area of the plane shape TQRS. But let's label our diagram. We have 3.22971 and we have 8.0741. So here we want to find the area of the plane shape TQRS. But to find the area of TQRS, we need to notice that now we can find this area by subtracting the area of the small triangle from the area of the big triangle. So if we find the area of the bigger triangle PRS and we subtract the area of the small triangle PTQ from there, we are going to find the area of the plane shape TQRS that is being shaded in the diagram. So now, to find the area of a triangle in a case like this, to find the area of a triangle in which we know the sides and we also know the included angle, you need to recall that the area of such a triangle, will be half AB sine C, and that is in this case scenario in which we know the angle C, and then A and B are the sides that are flanking the angle C. So A and B are the sides that are flanking the angle C. If you are to bring this in, we'll see that already we know the parameters for the triangle PTQ, but our parameters for the triangle PRS, they are not yet complete because we don't know the side PR. We don't know the side PR. The side PR is unknown to us, even though we know PS. So, to get the side PR, we can also employ the use of our similar triangles by relating the sides of the smaller triangle to the side of the bigger triangle. Using similar triangles, we can see that the line PT divided by the line PS will be equal to the line PQ divided by the line PR. The sides in relation to each other, they form this ratio. So 4 divided by 10 will be equal to 6 divided by PR that we are trying to get. Now, if we cross multiply from here, we can find our PR to be 10 times 6 divided by 4, which is 60 over 4, and that will be 15 centimeter. So PR is 15 centimeter. And so, knowing all this, we can now go ahead to find the area of the small triangle and then the area of the big triangle. We subtract the area of the small triangle from the big triangle, and the area of TQRS will easily come out. So we have 15 as PR, and then we also know our PS to be 10, 6, and 4. That is 10. So now, the area of TQRS will be half multiplied by 10 times 15 sine 30 minus half multiplied by 4 times 6 sine 30 also. Now we know sine 30 to be 1 over 2. So if you are to put that in the equation, we have 1 over 2 times 150 times 1 over 2 minus 1 over 2 times 24 times 1 over 2. We can cut out that we have 75 here. Then we have 2 divided by 24, 2 and 4. Okay, we have 6 here. And that will give us 75 over 2 minus 6. 75 over 2 is 37.5 minus 6, that will yield 31.5. 5.5 centimeters square. But we are asked to find this correct to the nearest whole number. So that will be equal to 32 centimeters square. Question number 10. Here we are given a triangle PQS. PQ is 12 centimeters, PS is 5 centimeters, and SPQ and PRQ is 90. We are asked to find Y, the line PR denoted as Y. Now, what we need to notice here in this diagram is that we are having two right angle triangles, and the right angles are being shown in yellow. And we are asked to find this line PR, which is being denoted as Y. So, how do we go about this? First, if we are to use Pythagoras Theorem, we can get the value of the line SQ. So, from the triangle PQS, we can use Pythagoras Theorem, and Pythagoras Theorem tells us that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Now, our hypotenuse in this case is SQ, which we are looking for. We know PS and we know PQ. So, you can say SQ square is equal to 5 square plus 12 squared, and that is 25 plus 144. That will give us 169, such that SQ will be the square root of 169, and that is 13 centimeters. So SQ is 13 centimeters. Then we can go ahead to see how we can find this PR, since we now know all the three sides of the bigger triangle. Now, there are quite a number of ways that we can use to get this value. If we are to draw out the triangle again, I will show two methods that we can use. We have a right angle here, we have 5, 12, and now we have 13. If we label our triangle, and then if we are to complete the triangle as given in the diagram, this is what we are looking for. Now, looking at this, one of the methods that we can use to solve this is to divide this base, the line SQ, we can divide it into two. Call one on the side x, and then the other side will be 13 minus x. And then, using this, we can employ Pythagoras Theorem and say, okay, now we have two triangles. If you are to look at the smaller triangle, the triangle to the left hand side, you can find that 5 square is y square plus s square, and to the right hand side, we can see that 12 square is y square plus 13 minus s square. Now, from both, we can say y square on both equation that we just wrote will be 5 square minus s square, which is 12 square minus 13 minus s square. So, using this, we can solve for x, and after we solve for x, we'll use the value in y. This is one way to go about it, but I'm not going to use that way. I want to use another method to try and find the value of y. Now, if I'm to take this angle at point S and call it theta, now from the triangle PSQ, we can evaluate that the trig ratio sine theta is equals to opposite over hypotenuse. So that opposite is 12, the hypotenuse is 13. Now, also from the triangle PSR, we can also define the same theta, sine theta is equal to opposite, which we are looking for, and the hypotenuse, which is 5. So that will be y over 5. Now, since it's the same value of sine theta, we can equate these two, 12 over 13 and y over 5, and we can easily get the value of y. And now, I took my time to break this down. Instead of just saying, let's use similar triangles, this is actually similar triangles. And when we cross multiply, y will be 12 times 5 divided by 13, which is 60 over 13. And if we bring in our calculator, let's bring in our calculator, 60 divided by 13, that will be 4.6154 centimeters. 4.6154. And if you are to find that correct to three significant figures, PR will be 4.62 centimeters. All right. Now here, question number 10b, we are given the length of two ladders L and M to be 10 meters and 12 meters, and they are placed against a wall such that each ladder makes the same angle with the horizontal ground. Now the foot of L is 8 meters from the foot of the wall. We are to draw this and then we are to calculate the height at which M touches the wall. Now for this type of question, a good understanding of all we are saying, what the question is asking, will help us to solve it. So if you are to draw the ground and the wall, and then we have two ladders. Let's say the first ladder here, 10 meters. Now, for them to make the same angle with the horizontal, that means inherently they are going to be parallel to one another. Because the angle here, theta, will also be the same angle here, theta. If you look at them, they look like corresponding angles that are facing the same sides. So that makes the 12 meters and the 10 meters, the ladders, that makes them parallel to one another. So now if you have to label our diagram, okay, now that's the first question we're asked to do. We've drawn the diagram, we've illustrated the diagram. So now we need to calculate the height at which M touches the wall. M, okay, maybe we can relabel our diagram instead of E and D. Maybe we can use L and M as given to us. Okay, let's use L and M. So we have L and M. Okay, so the height we are asked to find is from M down to point C. That's the height at which ladder M touches the wall. Now, if you are to look at this, how can we go about this? How do we go about this? Okay, we need to notice that we are having two triangles here, and for one of the triangles we know two sides, we don't know the third side. On the other triangle we only know one side, we don't know the other two sides. But again, we have said that the ladders are parallel to each other, and this is a right angle triangle, and they're also having the same base angles as noted in the diagram. So interestingly, we can use the principle of similar triangles to solve this, such that from the smaller triangle, let's say line LC is X, and then on the other triangle, let's say MC is Y. We can relate the length of the hypotenuse and the length of the opposite. Now from triangle BCL, the smaller triangle, if you are to use Pythagoras Theorem, we can find the value of X. So we know that BL square, which is the hypotenuse, is BC square, that's the adjacent, plus LC square, that is the opposite. So we know BL to be 10, then we know BC to be 8, and we are looking for LC, which is X. So S square will be 100 minus 64, and that is 36, such that our X will be square root of 36, and that is 6 meters. Now, we've gotten X to be 6 meters, and then we can go ahead to use the principle of similar triangles relating the ratio of the sides to one another to get the value of Y. Okay, I need to create some space on my workboard so that I can put the solution to Y right beside what we just worked out. So let me try and move this. Let me try and move this calculation that we have done. Okay. So I can erase the theorem so that I have my space. Okay, good. And now, since we want to use the principle of similar triangles, now we know the hypotenuse for the two, and then we are looking for the opposite for one. The ratio of the opposites will also be equal to the ratio of the hypotenuse. So x over y will be 10 over 12. And we have found our x to be 6. And this is directly coming from the opposite. X and y are the opposites. 10 and 12 are the hypotenuse. So now if we cross multiply this, we are going to have 10y is equal to 6 times 12. So y is 6 times 12, which is 72 divided by 10, and that is 7.2 meters. That is a solution to question number 10b of WAEC 2018. Wow. Here we have come to graph, and I know for a lot of students, this is a thorn in their flesh. But believe you me, it doesn't have to be. This is one of the cheapest questions you can attempt, and let's solve this together. So we are given y is equal to 2x squared plus x minus 10, and we are to complete this table for the values of x between minus 5 and 4 inclusive. And now that table is given to us. Now what I will advocate for is that you need to work smartly. You don't need to stress yourself just giving yourself a whole of headache, like saying you want to be substituting each value of x, like when x is minus 5, then y will be 2 into minus 5 square plus minus 5 minus 10, and then you want to expand that bracket, and after expanding the bracket, you also go on to the next value, then take s6. Now you have gotten this is, now y will be 35, then you also want to go to when x is minus 4, you also want to say y will be 2 into minus 4 square plus. Now the tendency for this is that you get bored easily and you lose concentration and you miss it. I'm going to provide a smart way to work around this with your calculator. For those of you using the functional scientific calculator, you can always input your equation, which is one of the methods I'm going to show. So first method is that now define your equation. When you press alpha and the second bracket to get x. So we want to put in this equation 2x squared plus alpha x minus 10. This is the equation we are given. And now what you want to do is you want to solve. You want to solve by this. You want to calculate. And now when you said calculate, it's asking for the value of y. And we put in minus 5. And when you press equal to, the value is out 35, just as we got the other time. Now, as simple as this is, you can also use it for each of the values of x. Now, when x is minus 4, your value is 18, and you do it continuously down to when you get 4. So you can just input your value and say, okay, now this is 2 into 16, and then you have 18. But I will advise personally that you just solve out your equation in the smart way using your calculator, and then at worst just write out the first line of an equation, and the next line you input your value. Now when x is minus 3 equal to your y is 5, as seen in the figure that was given to us before. When x is minus 2, the value is minus 4. So yes, minus 4, and you are good to go. As simple as that. And then you can do that for the whole of the other values. But now, I want to use another method. There is a table in your calculator. When you press the mode, now here in my calculator, 7 is for table. So when I press 7, it's asking me for the function of x. My function of x is y, because y is what I'm trying to solve for. It's a function of x, which is 2x squared plus x minus 10. Interestingly, I can also put in another function. So the calculator is also asking me, do I want another function g of x? Now, if you look at this question, in our question C number 2, we are given that 2x squared plus x minus 10 equals to 2x. the left hand side you will see is equal to y. So here is as if we are saying y is equal to 2x. So the second function is actually 2x. And knowing this, so right from the time I'm starting my calculation on the graph, I can input the two functions. So gx I will call 2x, and then I will go ahead to generate my table. I want to start from -5, so I press -5. I want to end at 4, so 4. And the step, the increment is 1, because -5 to -4 is 1, and on like that. And now, voila, once I press my equal to, my table is out for me. Now, x is showing the values that I'm inputting. Function of x is 2x squared plus x minus 10, and g of x is 2x. And easily with this, I've generated a table. I can confirm with the values that already have been given to me in the table from the question, but I will just input my values once I see that they tally, and I'm good to go. So I have 35, 18, 5, which is correct as given. And when x is -2, my y is -4, -2, -4. So now you can see when it's -1, it is -9. When x is 0, it is -10. When x is 2, when x is 1, y is -7. And all my values are already gotten for me. So using your calculator can really help you to work smart, so that you don't even miss any value. You get all your values and you are good to go. So now the first question on the graph is done and dusted. Then we want to go to our graph paper, and now we've been told the scale to use. We have to use scales of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis. And we have to draw the graph of y for the range of values -5 to 4. Now, on the graph paper is divided into squares, and now each of the squares is going to take some units. I've looked at the graph and cited where my center line should be, so that it will be quite valuable to see on the graph. So now I've noticed that my center coordinate should be towards the base of the graph, so that I will have space up, and then I can label 2 cm to 1 unit on the x-axis. That's why I have a gradation of 1. But on the y-axis, 5 cm to 2 cm to 5 units. So I have gradations of 5 on the y-axis. Now, having done that, I want to look at each corresponding values of x and y. When x is -5, y is 35. So at that point, I want to use the cross, yes. So x is -5, y is 35. When x is -4, y is 18. I have 15, 16, 17, 18. 15, 16, 17, 18. Okay. And then when x is -3, y is 5. When x is -2, y is -4. -4 just before -5. When x is -1, y is -9. 0 and -10. 1 and 7, 1 and -7, 2 and 0, 3 and 11, 4 and 26. Alright. Now, having done this, I need to join all my lines together. Now, if I'm doing this in the real life, I will use a French curve, or sometimes I use a broomstick. Yes, I remember those days. We used to use broomstick and you get your perfect curve. But now, I'm limited by my digital board. I will do my best to make sure I get a line of best fit. That is not it. I'm speeding up the video to show. Wow. No. No, that's worse. Okay. That's fair. Alright. This is not easy actually. Using your free hand. No. Alright. This is better. So yeah, joining the points, I've gotten the graph of y equals to 2x squared plus x minus 10. That is the graph as requested for me to draw. And now, once I've gotten this, that question number B is also solved. But now we have to use the graph to find the solution of 2x squared plus x equals to 10. If we take 10 to the left hand side, it becomes minus 10 equals to 0. That means the point at which the graph is equal to 0, meaning that y is equal to 0. That's the point at which you solve for this. And normally the language is that where the graph cuts the x-axis, where it cuts the x-axis, y is actually 0. So if you are to trace that here, let me use another ink. This is the first point and this is the second point. On these 2 points, these 2 points are the solution to the equation 2x squared plus x minus 10. And from the graph, if you are very observant, this solution amounts to x equals to, this will be minus 2.5, and then on the right hand side it is 2. So that is the solution to the graph 2x squared plus x equal to 10. And now for the last question number C2. Question number C2, as I was noting initially, 2x squared plus x minus 10 equals to 2x is amounting that y is equals to 2x. And then, okay, maybe we can draw our table to show the values of y for each value of x. Since we have another function here, we can draw our table. So now let me bring in the table for y equals to 2x. Y equals to 2x. I want to evaluate the values of y is 2x. Now, you remember when I was inputting my data into the calculator, I used g of x to be y. So you can as well just use your eyes to multiply 2x. That's quite easy. But sometimes the function may be quite a bit bogus, but then my calculator would have solved it out. So I will input all those values: minus 10, minus 8, minus 6, minus 4, minus 2, 0, 2, 4, 6, and 8, because it's just multiplied by 2. So now, if I were to plot this graph also, y equals to 2x is actually a straight line graph with, here, they are saying that there is no intercept, it's just y equals to 2x. But we are going to use that. When x is minus 5, y is minus 10. Now I'm using black ink. When x is minus 4, y is minus 8. Okay. When x is minus 3, y is minus 6. When is minus 2, minus 4. Okay. Minus 1, minus 2. And correctly, no intercept, 0 and 0. And then 1 and 2. 1 and 2. 2 and 4. 3 and 6, and 4 and 8. 6, 7, 8. Okay. Now, this is actually a straight line, so we can use a straight line. A ruler will be appropriate for this to join all the points together, and we can define that as y equals to 2x. Now, we've gotten our y equals to 2x, and then the solution that we're asked to find will be the point at which the line y equals to 2x cuts y equals to 2x squared plus x minus 10. And that is being noted in our colored ink again. So, from the graph, the point which is the solution to the equation 2x squared plus x minus 10 equals to 2x will be x equals to minus 2 or x is equal to 2.5. And that is as simple as it can be. You don't need to be intimidated with the graph questions. If you know what you're doing and you work smart, use your calculator as a tool to enhance your work, you can easily get your question without any hassle. Now, some people make it a point of duty to write the scale at the right hand side of the upper of the graph, the scale for the x-axis, the scale for the y-axis. Is a good thing to do, and it will earn you your full mark. So now our question number 12a, we are given that x is this matrix 2 and 3, y is matrix 5 and minus 2, z is matrix minus 4 and 13. Now we are asked to find the scalars p and q such that px plus qy is equal to z. All you need to do is just to bring in p and q into these matrices. So I'll bring in p and q into the matrix. We are going to have this. And then what this will form is a set of simultaneous equations, which we have 2p plus 5q is equal to minus 4. Then 3p, now we have minus 2q because minus 2 is there at the base, equal to 13. Now these are two equations that we can choose to solve, equation 1 and equation 2. We can solve them simultaneously and we can find the value of p and q. Now if you want to solve this simultaneously, let's say we want to use the elimination method. We multiply equation 1 by the coefficient of p in equation 2. That coefficient is 3. So we have 3 into 2p plus 5q equals to minus 4. And if we expand the bracket, that will be 6p plus 15q is equal to minus 12. 3 was used to multiply everything. Then equation 2 multiplied by the coefficient of p in equation 1. That coefficient is 2. So we have 2 into 3p minus 2q is equal to 13. So we have 6p now minus 4q is equal to 26. Now looking at these two new equations, 6p is common to both. So if you are to subtract the 6p's, we subtract themselves out, and it's as if we are putting the negative number into each value of this equation. So 6p minus 6p will be 0. 15q minus 4q will give us 19q, and we also have the other. So we have 0 plus 15q minus 4q is equal to minus 12 minus 26. So the two negative sign will turn to plus. So we have 19q is equal to minus 38. So that q is minus 38 over 19, which is minus 2. This value of q we can reuse in any of the previous equation we have found out. Let's say we want to pick equation 2. From equation 2, we want to use q equals to minus 2 in equation 2. So we are going to have 3p minus 2 into minus 2 is equal to 13. So 3p plus 4 is 13. So that 3p is 13 minus 4, which is 9. And p will be 9 divided by 3. And that is equal to 3. That is the value of p and q that we are asked to find. Now, question number 12b. Another graph for us. So students, as much as possible, please prepare to lay your hands on the graph. It's not as difficult as you think. Looking at this question now, we're asked to indicate on the graph the vertices and the coordinates of a quadrilateral WXYZ, and the values of the coordinates are given, and then we have to find the image rotated in an anticlockwise rotation of 90 degrees. This is where we want to have problem, but now the anti-clockwise direction is opposite the clockwise direction as shown on the board. So now, if we are to consider our Cartesian coordinates, I just want to use this to explain. If you are to turn this by angle 90, now, if you label it as this is y and negative value of y, x and negative value of x, by the time we rotate that by 90, this is what is going to happen. This x will move up, then the y will move to the left hand side, so it will become minus y. Then the minus x will move down, it will become still minus x. Then the minus y will move to the right, and that will be y. Now, looking at this, you can notice that it's just as if we are rotating the value of each of the coordinates. And this actually can be noted like this. Now, when you want to rotate in an anti-clockwise rotation of 90 degrees, this is what is going to happen. X will become y, and then y will become minus x. Now, let me just cite two examples that will clarify this. Just two examples that will make this very meaningful to us. If you have a point A that is defined as 1, 2, if you rotate it, anti-clockwise rotation, 90 degrees, x becomes y. So 1 becomes y, and then 2 becomes minus 2. Or we have B minus 3 and 4. So the new position will be x becomes y, it is minus 3, y becomes minus x, that will be minus 4. So with this rule of thumb, all we need to do is to apply this in the question that we're asked, and our solution will easily come out. So let's bring in our graph paper again. Let's find a way to bring our graph paper. Okay, before we do that, now let's say for these values that we are given, w, x, y, and z. So now the y1 that had been rotated, the w1 that had been rotated, I mean, now x will become y, x is now 2, y will become minus x, that is minus 3. The x1 that is rotated, now x becomes y, so y will be, then y becomes minus x, that will be minus 1, which is 1. The y1 will be x becomes y, so minus 4 is still, minus 3 is still there, then y will become minus x, which is minus 4, and that is 4. And then for the third one, x becomes y is minus 3, y becomes minus x, so that will be minus 2. So these are the values that we need to note on our diagram and we need to show on the graph paper. So if we bring in our graph paper now, and now this we can actually centralize. You can centralize on both the horizontal and the vertical axis. And I'm not going to note it, but I'm using a scale of 1 centimeter to 2 centimeters to represent 1 unit, 2 centimeters to represent 1 unit. So you have to put that 2 centimeters to represent 1 unit on both the x and the y axis. What I'm going to be having will be, let's say this is y, and this is x. Then on 0, what we are going to be having will be 1, 2, 3, 4, 1, 2, 3, 4, then negative minus 1, minus 2, minus 3, minus 4, then minus 1, minus 2, minus 3, minus 4. Let's start with each of these points. Now, we are told that w is 2 and 3, x is 2, y is 3, so that is w, this is 2, 3. Then x is 4, y is minus 1, 4 minus 1, so we have 3x 4, minus 1, y is minus 3, comma minus 4, minus 3 and minus 4. So this is y minus 3 minus 4. And then z is minus 3 and 2. Minus 3 and 2. Z minus 3, 2. So now to complete our quadrilateral, we need to join all these points. Let's do that. Let's do that, and our quadrilateral will come up quite easily. And just like that, we have completed question number 12b, Roman numeral 1. So now we can move on to the image under an anticlockwise rotation of 90 degrees. Now, W will be minus 3, 2. And if you're observant, that is exactly the same position as Z. So here we have W1 minus 3, 2. Then X1 is 1, 4. X is 1, Y is 4. 1, 4. So this is x1, 1, 4. Then y1 is 4, minus 3. X is 4, y is minus 3. So this is y1, 4, minus 3. And then z1 is minus 2, minus 3. So x is minus 2, y is minus 3. Z1 minus 2, minus 3. We can also join all these points together to show the image of the quadrilateral under the anticlockwise rotation of 90 degrees. And this is what we are going to get. Now, if you are quite artistic and you are quite observant, you will notice that this line and this line are equal. This line is the same as this line. Then you will just notice the symmetry about the rotation as requested for in the diagram. And it's just as simple as this. Finally, our last question on WAEC 2018 Mathematics. We are given a frequency table that is showing the mark distribution of a class of 30 students in an exam. The mean mark is 52. And from this, we also find the value of x and y, construct a group frequency table, starting with the lower class limit of 1, class interval of 10, draw histogram, and use it to estimate the mode. Now we have to come out with our table for these values because we want to sum everything. Now, x will be our mark, f is our frequency, fx is the product of the two. And then we want to replicate this information in our own table. Frequency is 1, 1, x, 5, y, 1, 4, 3, and 1. Now, the product of the two, of the mark and the frequency, is here. This will be 30x, this will be 200. Now, 50y, 60 times 1, 60, 70 times 4, 280, 80 times 3, 240, 90 times 1, 90. Now, the sum of these, you can find this sigma f. You can find sigma fx. Now, sigma f, if you sum all this, will be 16 plus x plus y. And then sigma fx will be, I think we need to bring in our calculator, 30x, 50y, and then all these other values. Let's input them. No, not f of x. We need to return to our normal mode. Okay, so 10 plus 20 plus 200 plus 60 plus 280 plus 240 plus 90. That's 900. Okay, so sigma fx is 30x plus 50y plus 900. But now, in the question, we have been told that the total number of students is 30. So the sigma f, the total frequency, which we got to be 16 plus x plus y, is actually equal to 30. we can note that because we are going to make use of it in finding the values of x and y. Now, I've cleared my table and I want to do the working now. For this group data, the mean is sigma fx divided by sigma f. And now, sigma fx we have found to be 30x plus 50y plus 900. Sigma f we have found to be 16 plus x plus y. Now, this mean had been given in the question to be 52. It had been given originally to be 52. So now, with this new expression, if you cross multiply with this new expression, three x plus 50y plus 900 equals to 52 into 16 plus x plus y. But alternatively, you could have said that 52 multiplied by 30. But let's go ahead. 52 multiplied by 16 is 832. 832. 52x plus 52y. So yeah, if we collect like terms, 30x minus 52x plus 50y minus 52y equal to 832 minus 900. So yeah, minus 22x minus 2y will be equal to minus 68. Now, all are divisible by 2. So if you are to divide all through by 2, we can have let's divide all through by minus 2, so that the negative will even cancel out. We have 11x plus y is equal to 34. So now, if you are to look at sigma f, that can also constitute another equation for us, because we will see that x plus y will now be 30 minus 16. 30 minus 16. 30 minus 16 is 14. So if you are to write that, x plus y is 14. Now, we have two equations. We can solve them by whatever method we want. Now, I can see that y can easily be eliminated if I subtract equation 1 from 2. Note I reversed my order. So I say equation 2 minus equation 1. 11x minus x will give me 11x minus x will give me 10x. Y minus y will be 0. 34 minus 14 will be 20. So x will be 2. Now, since I've known the value of x, I can substitute in any of these equations to get the value of y. Now, I want to use equation 1 now. So y will be 14 minus x, which is 2, meaning that y will be 14 minus 2, and that is 12. So what we are first asked to find is the value of x and y, and we have noted them to be 2 and 12. Now we have to draw our group frequency table. We want to get our class interval. It had been given to us initially using a class interval of 1 to 10. You can fill up all the table, for each class interval. Now, after filling this table, now we can get the upper class boundary. Now, the upper class boundary will be the first entry in the class interval minus 0.5, and that will be 1 minus 0.5, which is 0.5. The next one will be 11 minus 0.5, which is 10.5. The next one, 21 minus 0.5, 20.5, and on like that. Now, we could also have we could have found the extent of the class boundaries 0.5 to 10.5, but it's alright. This is sufficient for us to use in our histogram diagram. So, after finding all this, if you notice in my table, instead of x and y, I put in the value of 2 and 12 for the frequency. So now we can construct our histogram by looking at the x and the y axis. Now, I've scaled with my eyes to know that this is the best fit for my graph. So I have my frequency, I have my upper class boundary. So now, on the frequency scale, I'll be using a linear scale of 2 centimeters to represent 2 units. So my gradation will be 2, 4, 6, 8, 10, 12, 14. Now I'm having 12 as the highest number. But now on the upper class boundary, it's not going to be linear. I'm going to start with 0.5, then put in an increment of 10 as shown in the diagram. 0.5, 10.5, 20.5, and on like that. Now, if you want to draw this as an histogram, when the frequency is 1, my upper class boundary is 0.5, and then when it's also 10.5, it's still the same one. It is 2 when I'm going to 20.5. It is 5 when I'm going to 30.5. It is 12 when I'm going to 50.5. So we'll go to 12 on the scale, yes. Then it is 1 when I'm going to 50.5. It is 4 between 60.5 and 70.5. It is 3 between 70.5 and 80.5. So now you're going to draw the whole of this and join them appropriately. The last value is 90.5. So now with this, I've constructed my histogram with no space in between, which is the characteristics of the histogram, and then plotting the upper class boundary with the frequency. To find the mode, I'm going to look at the highest entry, which is 12, and then cross from the 2 side entries such that the point of intersection I can trace on the class boundary to note the value. And now for this is like this value now will be around 44.5. Yes, that will be around was 40, 42, 44, 46, 48, 50. Yes. So from the graph, the estimated mode now is an estimate. So there's margin for some allowances. From the graph, it is 44.5. You can say for the allowances plus or minus 1. And now that has brought us to the end of all the theory questions from WAEC 2018 Mathematics. The journey has been quite long, but we have reached the end. This is an exam prep, and sincerely speaking from the bottom of our hearts, we desire that you go out there and be the best in academics. Just don't forget to like the video, share it, subscribe to the channel, and until next time, God bless you.